Morning everyone, welcome to Basic Electronics 8, Lab 3. We're going to deal with, today we're dealing with potentiometers. Here's a couple right here. Capacitors. And diodes. Here's the diode. This is a 1N4007, and let me zoom in on this. And it's capable of, let me see if I can do it this way. Here is a 1N4007. And see that silver stripe? I think I said white stripe in the video. But the silver stripe, that goes towards the negative end, and this side is the positive to negative. And this is a, I think it's a 1N4007, and it's capable of 1,000 volts, 1 amp. Of course, we won't be using anywhere near that. But why are we using this now? We haven't used a protection diode or a power diode in any of our earlier labs or lectures. And the reason why we haven't is because at most, if you reverse the power in any of the earlier labs of lectures, the most you would do is maybe burn out an LED. But now we're dealing with these guys, capacitors. And this is a 1000 UF capacitor. And as you can see, there's the long side is the positive, the short side is negative, and there's those negative lines that I was talking about on the negative side. And this one, if I can read it, is a 10 UF capacitor that we're going to be using. And if you put these in wrong and there's enough voltage going through it, they will explode. They will. These guys have actually, if you notice on the top, they actually have these crisscross. So usually these ones will just blow their caps off. But still, it's not something you want to have to deal with. So if we use a power diode to make sure the current can only flow in one direction, we limit the risk we take when using our capacitance. So those are our capacitors. Here's a couple of potentiometers, trim pots. This is a single turn 100 ohms potentiometer, and I don't know what this one is. We're going to find out, and I can tell you right now it's a single turn, but I don't know. We're not going to use this one because 100 ohms we'd still burn out our LED, but we're going to figure that out. We're going to figure it all out and build our circuit right now. And here's our these are variable resistors, potentiometers, and of course here's our 470 ohms resistor, which I believe is yellow, violet, brown. And we'll even test that just to make sure. Okay, let's start our setup. First thing we're going to do is we're measuring ohms right now. So we're going to go start at, let's start at 2K ohms. And just to make everything easier, I'm putting my clips on, my multimeter. And we'll start with this guy. So I believe this guy is ACB. ACB. And we'll test that. I'm going to turn it all the way to the left. And one here. And one here. And for all intents and purposes, okay, it's not 0 ohms. With this turned all the way down, we're set for 200 here, and it's about call it 11, 12 ohms at its lowest point. Okay, well, I just turned it up and then turned it down again. We got down to 5 ohms. Now, let's turn it up, and it's a 100 ohms potentiometer, So even though it's a single turn, it's not like a 10K. So the variance isn't, we don't have this extreme variance. It's only 100 ohms. So we can get more precise with this one. I still wouldn't use it in like a laser power supply. Like if I wanted 12 ohms, to get that 12 ohms, we could come close, but it too easily would move in one direction or another. Okay, so let's go all the way up, and it's 105.6 ohms. So it's 100 ohms trim pot with 5% tolerance, and actually it looks like more like a 6% tolerance. So it gets about what we want. Now we can't use this in our circuit because in our circuit we need at least 470 ohms so we don't burn out our LED. So let's put this trim pot aside. This is one you would see in a car stereo. You'd have a knob on top and you turn it. There's a screw here, so you can, like, we'll have project boxes, and we'll put these into a project boxes and put this through a drilled hole, and then fasten it to the project box with this bolt right here. So this is another one. This actually came in Adafruit. Has a microcontroller experimenter's kit, which is awesome. I highly recommend it. We'll be doing some of the experiments from that, and it includes an Arduino microcontroller. We're going to go all over microcontrollers. It's got things like piezo buzzers, relays, switches, some motors, some resistors. It's got those nice wires we like to deal with on the breadboard. It actually has a breadboard too. But anyways, this is from her kit. And actually I'll put a link down below. And we need to test this. So looking at this, I believe if I turn it all the way to this direction, in this direction, this should be A, C, B. So we'll leave it at 200 ohms. We don't know what it is. And we're going to connect to the A, and we'll connect to the C. And it's reading 6 ohms. Now we'll turn it up. Oh. And we already went well above. Now make sure these aren't touching. Another thing you can do if you want is you can put it in your breadboard. Here I'm putting it in 14, 15, and 16 on the breadboard. And it's hard to see where they were going in, but 14, 15, and 16. I put it in there. And then I take some wires, and let me use different colors. We'll just use red and black. Remember, resistance isn't, there's no polarity in resistance, so it's not something we have to worry about. So 15 and 16. And let's connect it again. I'm using red to black here. I can use red to red if you feel more comfortable. But there's no polarity, so it doesn't matter which way we hook it up. Okay, let's turn it all the way down again first. And we're reading about 7 ohms. These are like the least expensive multimeters I've found. They're not the best, but they're good enough for most of the stuff we're going to build. I actually have some better multimeters that we'll go over as well, auto ranging and some nice scopes and stuff. But I know I told you guys at the beginning this is the meter we're using. So this is the meter we'll be using for the majority of our testing. Okay, now let's slowly turn it up. It's a single turn. See, we're up 22 ohms, 20, 48, and we've already exceeded the 200. So now let's go to 2K. So by turning this, I'm already up to 864. Let's keep going. Wow. Oh, I'm sorry. It wasn't. It was 864 ohms. So now we're at 1.3K. 1.8. And boom, we've gone over 2K. So now we go bump our multimeter up to 20K. See, we're at 2.7K. And we continue to climb 3K, 4K, 5K, 6K, 7, 9, 10. So 10.29K. So this is a 10K potentiometer. And we can do some fun stuff with this. Actually, we're going to use this for our circuit. So the first thing I'm going to do is try to get it down. It might be a little tough to make this around 470 ohms, but that's what I'm going to do initially. Let me get down to 2K and bring this down. So it'll be 0.470 is what we're looking for. Is 800. No, I think it's going to be 2. So there's 483. We should be able to use that for our circuit. But actually, before we even do that, before we get into the potentiometer, let's build our circuit without the potentiometer. Okay, here's our breadboard. So the first thing we want to do is we want to include our power diode. And remember, the gray, silver, or white, depending on the diode you have, wants to go towards the negative. So what we're going to do is our power is going to go up here in this first rail. And then our power diode is going to go from here into our power rail. So we're not plugging the power directly into the positive power rail. The reason we want anything we plug in to this rail to be protected. So we're actually going to plug our power in here, and I'll take a closer shot of this when it's done. We're going to put it in, right now it's in 1J, and then it goes into the power rail. But we want to take our power too, and we're gonna go back to using the 9-volt battery for now. And so we're going to take the positive, and we're going to plug it into 1F right here. And then the negative, of course, is going to go into our negative rail over here on the opposite side. Now it's less risky. I can put the negative over here now because it's less risky. If I accidentally switch something over, I'm actually protected by the power diode. But still, I like to keep it separated. Okay, let's test our power. Let's make sure we have some power before we do anything else. Red to red, because now we're testing voltage, so it matters for our testing. We'd get a negative reading if we plugged it in wrong. But initially, what I'm going to do at first, and let me zoom in on this, and we want to get the multimeter in here too. We're going to turn to voltage. I'm going to turn to 20 volts. 20 volts DC. AC, of course, is up here. And I'm going to take the positive, and I'm going to put it in 1H before the power diode. And then I'm going to put the negative in the negative rail. So what we're doing is we're taking a voltage reading prior to using the power diode. Move this back a little more. So I have in the negative rail the positive, and I believe it's 1F. H. It's 1H. So I'm measuring the current, the voltage, sorry. I'm measuring the voltage prior to it hitting the power diode. And we got 8.99 volts. We'll just call it 9 volts. Now I'm taking the positive out of the top of that, and I'm putting it into the power rail. And we've got 8.6 volts now. So the diode is actually absorbing approximately 0.3 or 4 volts for us. You know, almost half a volt. So as we add these components to our circuit, once again we go back here, 899, and then we go into the power rail, and we've got 8.60. So we've reduced our voltage going through this power diode. So now we only have 8.6 volts to play with. Okay, so we have our power diode. Now the next thing we want to do is we want to take our capacitor. Now of course I gotta get a bit of setup here. so you guys can see what I'm doing. We have the 1000 UF, the big bad boy here, and we have the 10 UF. Both electrolytic capacitors, both have polarization. We're using our power diode to make sure we don't hurt anything. Normally you don't use capacitors to power LEDs. We're just doing that so you can see what they do. We have long end on the positive side, short end on the negative side. So what I'm going to do is I'm going to put this capacitor into row 7. And I'm going to put the positive end in, let's call it 7H, and then the negative end over in 7C. Now if you remember, actually let's do 7D. If you remember, this line and this line they're not connected. They're separated by this bridge. So we have in 7H here, 7D over here. So we're still not connected to the power. If I turn this in this direction, you see this is the positive rail, and nothing's connected here yet. Now I'm going to do the same thing for my LED. I have a couple of different LEDs here. And of course I have a 3-volt battery, not a 1.5. This is a 3-volt battery. And this LED actually requires a lot less power. Now let me test it before we put it in our circuit, make sure it works. It does. Than these two. So we're going to use that one because it might be powered longer by this capacitor. This, of course, is our blue. And this, even though there's only 2 prongs on it, this is a red, green, blue color changer. And it does it slowly. I'll put a link in below if I can find them on eBay again. I usually try to buy like a 1,000 or 500 at a time because these are handy and they make for nice little projects. But they also require more power than this little tiny guy here. So once again, with the little LED, we have the long side. The long end is positive. So we're putting this side, we're making this side kind of positive and this side kind of negative. So we're putting the long side, we're going to put it in 12H, and the negative side in 12D. So now we've got our positive side and our negative side, and I could tell there's a little flat surface on this end as well. So once again, this guy isn't hooked up to power either, because this row 12 is not connected to power. We're going to do that in a minute. Okay, so what we want to do is we're going to take some wires, we'll take a white one, and we're going to go from our positive rail. Let me fix this a little bit. Yeah, that's better. Let me zoom out a little. I'll pull this up to the camera when we're done. But I'm going to go from the positive rail over to the positive side of the capacitor. Actually, let me move it up a little more. So from the positive rail to the positive side of the capacitor. Now, I've got to connect that positive side to the capacitor over to the positive side of the LED. Now, one of the things I could do, if I was trying to save space on my board, is I could take out the LED and I could just put it into this positive side here on this row 7. Put it anywhere on this row 7. Because like I said in my schematic, they're connected together. But just for now, I'm going to keep it separated, and I believe I had it in 12H and 12D. And I'm going to take another wire, and I'm going to go from this positive side of the capacitor over to the positive side of the LED. Oh, I'm sorry. See, this is what happens with live experiments. What I meant to do was to take the resistor and go from the positive side of the capacitor. So you wouldn't actually put this in. You'd fry your LED if you put that in there without any resistance. from the positive side of the capacitor over to the positive side of the resistor. And if you're keeping track, it is in row 7, row 7J to row 12J. Let me put that up closer. So that's how we're connecting. Now I could actually connect this to a wire. We could do it a whole bunch of different ways. But so basically I'm connecting these two positive ends through this resistor, so it's providing the resistance prior to the LED. Now if I put the LED back, like I said, then I could go to the resistor, like I said, because the resistor doesn't make a difference. So if I put the LED up in the positive end and then put it down in one of these rows and did the resistor on the back side, on the negative side of the LED, over to the negative ground, then that would work too. But right now we're just going to put it in 7J and 12J, just like that. So now, if you remember from our schematic, we actually had two grounds. Let me use, I'll use two yellows. So we actually had two grounds. So one ground we had for the LED and one ground for the capacitor. So let me actually unplug the power on this, because usually you don't put your power into your circuit until you're actually done with your circuit. And this guy he shouldn't have any capacitance because he wasn't connected to ground. So first thing I'm going to do is I'm going to put this in 7A to the ground rail. So we have the negative side of our capacitor. Now if you remember, we also wanted the we also have to ground the negative side of the LED. Now what I could do is I could plug this into 12A, and if I wanted to I could plug it into the ground side of the capacitor, or I could plug it directly into ground, which is what I'm going to do. So you saw those two ground symbols, and remember I said I could either connect each one individually through ground or connect them together and connect, you know, that wire to ground. Either way you could do that. So now we have our circuit, and let me just double check, because usually if a circuit doesn't work, it's it's our fault. It's usually not a component. So let me review this. We have positive power going into this top 5 connected holes. Then we have our power diode, which goes from that top row into the positive rail, then the positive rail into the positive side of the capacitor, then the resistor goes from the positive side of the capacitor to the positive side of the LED, and then on the other end we have the negative side of the LED connected to ground and the negative side of the capacitor connected to ground as well. So it looks good. Let me hold that up. There's our circuit. See if I can't get a picture of that. Let's see. Okay, let's see if we can take a snapshot. Okay, you can always hit pause. Okay, so now we have our completed circuit. Now, if I plug in this battery, our little LED should light up. And voila. We have power. We have our little LED. Now, if I disconnect this, the capacitor should power the LED momentarily. And let me disconnect, and there it goes. It starts to dim. See, we used a very big capacitor and a very low wattage LED. Let me do that again. We're actually going to switch out the LED so you can see the difference. So here we are with power, and then I'm going to disconnect the power. And the capacitor with its stored energy is powering the LED momentarily. So now let's put in a stronger LED. Let's find our blue LED here. All I'm doing is I'm taking this battery, positive side to the positive side, negative side to the negative side. So this is our blue LED, and I'm replacing it to where the other one was. I'm going from actually H12 to actually 12E, which is still spanning the bridge. It's just not the same one that the other LED was in. So now I gave this guy some power. And we see our LED is nice and bright. and then we remove the power. That still does a pretty good job of powering that LED for a little while. And once again, power, and then no power. So that's what the capacitor does. It holds that energy, and the diode makes sure that if we plug this in backwards now, which is what I'm going to do, I'm going to touch these backwards, it should provide our circuit protection and not let things flow. Now if I didn't have this, this guy would heat up. If I didn't have this power diode, this guy would heat up. So right now we're connected backwards. Let's see if we blew anything up. Nope. We connected the correct way and we're okay. And our capacitor wasn't getting hot. So that's a 100 UF capacitor. Now let's replace it with a 10 UF capacitor.